Hello and welcome back. We're going to be working on the OLI mod guide for Module 7 today. We're going to introduce ourselves to StatCrunch for the first time and log in with that. I will show you how to do that as well. First, we've got some definitions, categorical versus quantitative variables, and I think that the definition that's given in the OLI text is, it's okay. They say that you're taking categorical or label values and placing an individual into one of several groups, and each observation can only be placed in one category, and the categories are mutually exclusive. So what that means is, let's say I'm talking about eye color, and I have blue, green, black, brown, hazel. I I want to make sure that I can't put an eye color into both categories. It has to be one category. It can't be more than one. That's what mutually exclusive means. It can't happen at the same time. So when you think about categorical variables, the way that I think about it is sometimes numbers are actually categorical variables. It's something that doesn't make sense to take the average of. So for instance, a zip code, a zip code is not a numerical variable. It's actually a categorical variable because it helps tell you geographically where you're located. It doesn't make sense for me to take the average zip code. Same thing with like an area code. Even though those are numbers, we would not consider those to be quantitative variables. Quantitative variables are numerical. They represent some sort of measurement like weight or height. Those are typical quantitative variables. In our first Learn by Doing for this section on page 29, we're talking about cereals. There's 77 breakfast cereals that we have listed in StatCrunch. And from this snapshot, we're going to answer a few questions first. So what are the individuals? The individuals are the different types of cereals. I'm asked how many variables are shown in the screenshot. Well, if you notice up here in the first question, they said that there's 77 breakfast cereals here, but in this data set here, there's only 7 that we can see. And then we're asked how many variables are in the screenshot. Well, we have a manufacturer, we have a target, we have a shelf, calories, sodium, and fat. So I'm looking at caloric value for cereal, sodium value, and fat values. Shelf is where it's located in the grocery store. It's actually strategized where sugary cereals will be lower at kids level so that they would try and encourage their parents to buy it, and all of the more healthy cereals like natural brand and all brand are at the top. So notice that cinnamon Cheerios is at the bottom and Apple Jacks is at the middle. How many variables are shown in this screenshot? We have 1, 2, 3, 4, 5, 6. And name is going to be just representative of an identifier, not necessarily a variable. And the categorical variables, these are the ones that are categories that we can't take averages of. We have a manufacturer, we have target, who are we targeting, and we have the shelf. And then in terms of quantitative variables, we have calories, sodium, and fat. Now, we're wondering whether I get this. So on the next page, we are looking at a couple of graphs. And this is about animals. We're going to come back to cereal data in just a second, but we're talking about the different types of species of animals. So there's data here for 30 different types of animals and the lifespan, which is their age in years. So that's a numerical value. The different types of species, that's going to categorize them. And they want to summarize the distribution of lifespans. The way in which we summarize distributions, which we're going to do on the next page, I prefer to use the acronym SUCS, something that I picked up from a previous textbook, and we'll kind of dip our toes into the water with this as we get into further modules, so you might not necessarily know what these different terms are that we're talking about. Shape is the first one. Unusual features is the second. Center is the C, and S is the second, is the fourth letter, but the second S, which stands for spread. And we'll have different measurements for center and spread. Shape we'll talk about in a little bit. Sometimes people will use the acronym SOX, where the O stands for outliers. I like unusual features though, because we don't want to just talk about outliers. If we have gaps like we do here, we would want to mention that. Okay, which graph is best for summarizing the distribution? Well, when we're analyzing these graphs, I'm going to make it a little bit bigger so that you can see. Notice on the x-axis here, I have cage number, and down here, I have lifespan. Well, cage number, it doesn't matter a hill of beans which cage number the animal is in. That doesn't mean any difference into how long the animal is going to live. But the lifespan is going to help me with some sort of information. When we're talking about a distribution, we typically are looking at univariate data, which means we're talking about one variable, and we want to deal with their numbers. Now, graph A, each of these heights represents the lifespan, but it's very hard to tell. There's not really any grouping because of the fact that they have cage number on the x-axis. So I think that this graph is not very good at all. I would definitely tend to look at graph B because we have the lifespan in years, which goes from 0 all the way up to 40. And so you know that there's not a long lifespan and there's a lifespan of 40 years. That clearly displays the graph. So I would say that graph B is best for summarizing the distribution. And summarizing a distribution is a set of numbers. That's one thing that we'll refer to it as a distribution. Here, this is kind of like a dot plot, except instead of dots, they're using boxes. We'll make dot. You saw dot plots on Mod 6 when we were looking at the Mozart and Anthrax music. Those were dots. This over here on the left is a histogram. And a histogram looks kind of like a bar chart, except they touch. And this could have been a good histogram if they had switched and put lifespan on the bottom axis. For part B, which are accurate statements about the distribution for this group, a typical lifespan for the species is 12 or 15 years. Typical. This is a word that's kind of gets thrown in there, but it actually has a lot of relevance in our class. Typically means a central value. So whenever we say typical, we're talking about a central value. Right over here, again, remember when I said we're talking about a distribution, we said center. Let's get used to using the word typical with that. We're looking for 12 or 15 years. So here's 10, here's 20. That's about 12 or 15, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of those that are 12 to 15. That's about in the center. I would say that that's valid. Lifespans ranged from a year to 30 years. Well, no, we have one that goes up to 40, so I would say that that's not valid. Over half the species lived from 12 to 20 years. 12 to 20 would include all of these. So we have 11, 12, 13, 14, 15, 16, 17. So we have 17 total out of the 30. That's more than half. So for sure, that's a valid statement. And then it is unusual for an animal species to live longer than 25 years. Well, there's one here and there's one here. That's not a lot. That is valid. All right. We're going to pause here and move on to the next video where we will work on StatCrunch.